we are going to look at bio-photonic communication today. What is bio-photonic communication? Well, I'll show you. So this is big tech. Biologic internet gateway technologies, this idea of decoding the human and fusing it or merging it with the internet. And the internet of tomorrow is not like the internet of today. The internet of tomorrow would be more closely defined or understood using quantum mechanical principles. So if you're not in YouTube, you can get to the notes if you go to PATRIOT'Ssoapbox.com, go to the shows tab, find the show banner, and then look for the section on this page that says read, watch, think for yourself. And there's a link there, Big Tech Notes and Archives. When you get there, you will see something that looks like this. We are on episode 83. The archive notes are broken down into groups of 10. And when you select the appropriate link, you will get to a page that looks like this. On this page, you will see a link to the archive, so you can jump back real fast to get to previous notes. There's a lot of good information there for those of you that want to start exploring tech through my eyes, so to speak. There's great stuff in the archive. Humaninternet.org, it's a website that I'm building. This is an ongoing endeavor. It's not perfect, and to some extent, I'm glad that it's not. I'll give you a sample of what this looks like. On humaninternet.org, you can find a media section, and I'm downloading and re-uploading these episodes so that they are diversified in the event PSB's channel goes down. But there's a whole bunch of other video sections. There's sections on brain communication, remote control, radar technologies, what they can do with power lines, particularly in your house, directed energy systems or weapons, wideband and Wi-Fi technologies. I'm working on quantum communication, bioenergy interfaces, wearable technologies, watch, headphones, antennas I'm going to build out. That's an upcoming project. And then there's all kinds of stuff that they can do with cameras. For those of you that are new, camera technology, just to give you an idea, they can estimate your brain activity with a camera, and there's breakdowns of how this is done. They can determine your emotional state using a camera, happy, sad, angry, frustrated, amongst other things. And remote monitoring of your vital signs, heartbeat, respiration, all those things tie into establishing or evaluating your emotions and or your response to stimuli. So when you're looking at Twitter, watching a YouTube video, playing around on Facebook, or reading email, you exert or exude a lot of interesting characteristics that the camera can pick up and then be processed with the algorithms to evaluate your proclivities. Single channel imaging, measurement of dynamic changes in heart or respiration, and it goes on and on and on. So there's an example of the kind of stuff here that's on this site. There's nanotechnology, brain stimulation with nanotechnology, a couple different patents on how they deliver nanotechnology into a human organism or a biologic organism, magnetic nanoparticles, synthetic biotechnology, cyborg cells, that's a whole section on Charles Lieber, and quantum dots. The welcome page looks like this, and it clearly states here this site is under construction, and it will be for some time. And that's humaninternet.org. We, like I said, are on episode 83, and we are going to look at this document, a heuristic view on quantum biophoton cellular communication. And I looked this guy up, Charles L. Sanders, who wrote this. And he's listed as an independent researcher. So you think, all right, well, who cares? And then I looked him up, right? And he's a professor at Korea Advanced Institute of Science and Technology. He's a professor in the Department of Nuclear and Quantum Engineering. in South Korea. And South Korea is rated as one of the highest tech, quote unquote, countries out there. And when you look at some of his publications, they run the gamut, right? Here's the one we're going to look at today, quantum biophoton cellular communication. He has done research and published papers on different ionizing radiation exposures. He has some on non-ionizing radiation exposures. Some of this I'm going to look at myself later. I found this today, or researched the background of this guy a little more intensely today. Radiological weapons, talks about nuclear bombs, dirty bombs, and others. Radiology or radiobiology and radiation hormesis, new evidence and its implications for medicine and society. So this ties in very closely with what I find interest in researching. And there was another one in here, speculations about bystander and photons, or biophotons, excuse me. Health protection policies on low dose ionizing radiation. Yeah. So the link to what we're going to read is put underneath episode 83. And from there, you can literally just click on this guy's name and look more into what he writes about. To me, it's very intriguing. Nonetheless, it's a 28-page document. I doubt we'll get all the way through it today, but we're going to start and see how well we fare. So it looks like here, this is just one chapter out of a book or a larger paper, Radiology and Radiation Hormesis, New Evidence and Its Implication for Medicine and Society, right? That was the one that actually caught my eye when I was looking through his collection there. And what this chapter is, chapter 8, Heuristic View on Quantum Biophoton Cellular Communication. And what's interesting is he quotes something from scripture, basically. Jesus said to the people, I am the light of the world. If you follow me, you won't be stumbling through the darkness because you will have the light that leads to life. Quantum biology, everything is running through a computer now, and applications are happening at an increasing pace. They encompass augmented reality and virtual reality. Augmented reality increases the integration of information into your life. The integration is performed through an interface which determines how you interact with the computer. Virtual reality allows you to log into any part of the world and experience reality as if you were there. Augmented reality provides a world of enormous amounts of information that you see integrating with the entire world. So it's like an overlay. Instead of it being a completely virtualized experience, right? Virtual reality, augmented reality is an overlay on top of reality. Whole lives can be built in a virtual existence where others can interact by meeting in a virtual location and not needing to travel to interact, right? So what this means is there are many different ways to perceive our world. And with COVID, basically began the forced rollout of a virtualized existence. And the question really becomes, what is a virtual existence and how far down that path are we, meaning the human species, how far down that path are we going to go? And then what does the future look like with augmented reality and virtual reality blended together with our world, with reality, what we perceive as reality? And this is the future space of the internet. This will be the future space of how we communicate. And so these are very real things, and these are very forward-thinking things at our level. Yet these things have been discussed ad infinitum amongst the chambers that exist in those smoky rooms and in those boardrooms. So we need to catch up. We need to understand what it is our children are doing with modern communication devices, with virtual reality apparatuses, the things that you literally put a phone into a harness and strap it on your face. And that's like the future of gaming at this point, which is only a step into where we're going. We're going to direct neural interfaces that are going to deliver active hallucinations, basically, straight to your cortex, straight to different regions of your brain. So all of this ties together in a beautiful way, but also in a very scary way. And like I said, we have to start really thinking about the implications of these things, and how powerful they are as systems to enhance our existence, but also as systems of control. So here we go. A number of experimental groups around the world are investigating the outlandish but not utterly inconceivable hunch that the boundaries of quantum theory have to do with the complexity of a system or even with life itself. China is developing quantum communication technology with the launch of the satellite dubbed Quantum Science Satellite, designed as a hack-proof communication system for transmitting undecipherable encryption keys from space to the ground that are immune. They are immune to cyber attacks. The satellite will teleport entangled photons from the satellite to relay stations separated by about 1,200 kilometers. The Internet of Everything is a global network that intends to connect everything by transportation, teleportation, and telepresence, where trillions, with a T, trillions of connections create unprecedented opportunities as well as risks. The Internet of Everything is scheduled to be operational by 2020, when nearly 100% of Earth's inhabitants will have access to the Internet. The Internet of Everything for the Earth has similar quantum correlations with communication in and among human cells of the body. I'm going to read that last piece again. The Internet of Everything for the Earth has similar quantum correlations with communication in and among human cells of the body. So now they're making the link here of creating an internet synthetic that matches or mirrors what's going on inside of a human body, right? Quantum biology is where physics meets biology. Both classical physics and quantum mechanics may be operational in cell communication. Each living cell talks with other cells with incredible precision and accuracy to maintain synchrony, unity of purpose, and health. Each cell may be envisioned as communicating intelligence. The vehicle for cell signaling and passing information is either chemical reaction, an electromagnetic wave, or by quantum transfer, or all of the above. Electromagnetic signals for biosystems have several advantages, including speed and coherent behavior. Data communication of unbelievable complexity occur within each cell millions of times a second and among nearby cells and cells at distance. The speed of communication may be of light for biophotons or faster or even instantaneous for quantum transfer. So what are we looking at here? We have electromagnetic waves, we have chemical reactions, and we have quantum information transfer that's all occurring in the body. And when we look at what we're constructing around us, that's exactly what we're building, right? We have chemical compounds. You can equate that to food, water, air, medication, etc., even cosmetics for that matter. You have electromagnetic waves. That's pretty obvious, right? And this idea of quantum. And this idea of quantum is not really being talked about a lot. if you've been listening to this show for a while, we went over the quantum initiative, the AI initiative. Basically, they were kind of the same. They're fused into the same idea, where the White House wants to spend $2 billion with a B, $2 billion over the next few years, building out AI and understanding quantum sciences. There's a reason for that. It's a lot of money, and that's for non-military research purposes. So what I think we're building with 5G, just to use that as an overarching framework, we're building a conventional internet, right? The next step, the next stage. We went from 3G to 4G to 5, now we're going to 5G, right? But that's going to provide the platform which will enable very efficient quantum communications. So a quantum network is being constructed in parallel with the internet that we're going to have access to. And so the question really then becomes, what are we doing with that? When I say we, I'm talking people in general. So the other piece I want to, I guess, expound upon is this idea of instantaneous communication. So when quantum communication occurs, we're messing around with this idea of information exchange at the speed of light, or perhaps even faster. And to some, to conceptualize or understand the speed of light being what we understand is the fastest thing anything can go, you would naturally think, well, nothing could go faster than the speed of light. So therefore communication cannot go faster than the speed of light. But that's where quantum mechanics comes into play, and this idea of entanglement, and this idea that if you generate two photons out of the same generator, it doesn't matter how far apart those photons get. When you manipulate one, the other will respond with some predictability, with some probability. And then lace together the idea that if you had a quantum network where everything was timed, you could then generate photons at one location and have a mirroring generator or many mirroring generators to create entangled photons that literally simulate being paired together at two different locations. And I'll stop there because it's even bending my mind when you think about the complexities of what a quantum network will look like when you start doing things like a man in the middle. For those of you who don't know what a man in the middle is, a type of a function on the internet, it's where something is inserted between somebody who wants to send an email to somebody else, right? But a man in the middle will intercept that email and look at it, copy it, do whatever they're going to do with it, and then send a copy on to the sender. Or the receiver. So the sender and the receiver, they get their normal communication. The email is sent from person A to person B, but the man in the middle, when they exist, also gets a copy of that. And so the way they're selling quantum is that it's going to be unhackable, completely encrypted. This is where cryptocurrency is going to live. This is where blockchain is going to live. This is how super secure communications are going to occur. And I think it's a sales pitch, because the reality is they would not deploy this without an ability to have a master control switch, master control platform on top of it. And that's why, in my mind, when I think about a quantum network, quantum internet, if you're going to generate entangled photons that are supposedly going to be totally secure, and that if anybody looks at it before it gets to its intended destination, that information is destroyed, completely secure communications, there's no way, absolutely no way they are going to deploy that in the public sphere. When you look at the behaviors of government, and when you look at the behaviors of the intelligence community, and you look at the needs and necessities of governments to try to protect themselves from others, or people for that matter, try to protect themselves from others, that kind of technology is just not coming out without an overarching way to read what's going on over the internet. So there's a lot more going on with the quantum internet than the sales pitch of, oh, we're going to deliver super secure communication between banks. Banks are going to bank with us because we use quantum encryption. There's nothing that can crack that. Yeah, well, believe that if you want. I personally don't. I think that what's going to happen is they're going to have mirroring devices. So when a quantum communication is generated, they will have something that mirrors it and it will immediately be understood, or they will be able to read and sense what's going on in the quantum internet without disturbing it, which takes me back to the $2 billion with the B that the White House is putting into non-military research for quantum sciences and AI, because those two go together like a horse and carriage. AI is going to be needed to be able to run quantum networks. So that being said, back to the biological piece, our bodies function in that realm. This idea that your DNA from your toe is able to send communications throughout your entire body and have it instantly be able to signal DNA, let's say in your brain or anywhere else in your body for that matter, for the body to understand what's going on with each cell in real time. When you think about how many cells you have in your body, just ask yourself, how does that happen? How is that possible? All of those things that happen in your body that you literally don't consciously process. How does your body know to make protein to repair a cell? How does your body know to get rid of waste? How does your body know to remove a dead cell, to change a stem cell into a liver cell versus a heart cell, to steer those cells from the generator locations to the right place in the organ? And the simple answer is through communication. It has to have a send and a receive type of a communication through your body. And so there are many ways that that's done. Chemicals, electromagnetism, and quantum communication. So here we go. The cell is the irreducible minimal unit of life. Most of each of the 3 trillion cells, over 100 cell types in the adult human, undergo an incredible number of chemical reactions per second. The brain has 100 billion neurons with many trillion of synapses. Cell metabolism is total energy released and consumed by the cell. All chemical reactions happening in the cell and in all cells of the body. Just look at energy production alone. ATP, energy used by the human body, requires the hydrolysis of 200 to 300 moles of ATP daily. 1 molecule of ATP synthase produces 600 ATP per second. Each ATP molecule is recycled 2,000 to 3,000 times a day. A single cell uses about 15 million ATP molecules per second. ATP is just a measurement of energy, basically energy conversion that your cells need and use. 15 million ATP molecules per second. A single cell uses 15 million ATP molecules per second. Recycling all ATP molecules about every 20 to 30 seconds. Another example of cell complexity comprises catalytic proteins. The largest component of total cell dry mass, which are catalytic proteins, which are used to build molecular constituents of a functioning cell. So these are the building blocks that make a cell actually have a physical form, shape, and function. Catalytic proteins, the largest component of total cell dry mass. Superoxide dismutase and carbonic anhydrase alone may carry out 10 to the 6th power to 10 to the 7th power reactions per second in one human cell. So we're talking about 10 with 6 zeros after it, or 10 with 7 zeros after it. That's million, or tens of millions, right? Reactions per second in one cell. One cell. A million to tens of million reactions per second per cell in your body. And then how many cells do you have? Enzymes may increase rates by an astonishing 10 orders of magnitude, which, okay, so the base level of reactions per second in one human cell is from 1 million approximately up to tens of millions per second. And then introduction of certain enzymes into cells, right, increases the rate by an astonishing 10 orders of magnitude. That's a lot of zeros after a 10 happening per second inside of one cell. And these communications, or I'll restate that, the communications necessary to be able to have the rest of the body function in harmony while all of these reactions are occurring at the same time. Keep in mind, right? 1 million to upwards of tens of millions, and on occasions, probably on a regular basis with enzymes, 10 orders of magnitude over tens of millions of reactions happening per second in one cell. And you have all of the cells doing this all at the same time. And you have communications that occur in the body that are coordinating, understanding, interpreting, and compensating for these reactions or for certain trigger events during these sequences of reactions. That's a lot. And so the best way to really approximate that or liken that, think about the number of connections on the internet today. What does the Internet of Things look like? What does the Internet of Everything look like? How many independent, unique internet connections are there? Now take a company like Google or Facebook. How many connections do they have access to every second? How do they manage that? How does the NSA or affiliate counterparts in other countries manage all of these connections that comprise the Internet of Things and the Internet of Everything when we have billions, soon to be trillions of independent connections on the internet? How do you manage those in real time? It looks a lot like what we're looking at here inside of a human body. And at this point, with these amounts of reactions or events and or connections, you need AI. There's no way that mechanical switching, mechanical recording is going to work. There's just no way. So you're going to have to virtualize it. And I'm talking about the synthetic internet now, right? Google, Facebook, those kind of companies who are responsible for managing the cloud, or at least the information in the cloud. And then you've got telecommunications companies that have to route all the traffic. They have the same challenges. It has to be done with AI. And at this point, it's going to be done with quantum computers to leverage this idea of probabilities so that you can more efficiently manage energy consumption. You can more efficiently manage bandwidth and all of the necessary components to achieve reasonable network management. And I use that term euphemistically for those of you in the tech world or in the communications world who listen to this and maybe aren't saying a word. Reasonable network management. That is a term that will be used. It is used in literature that passes through the halls of the FCC and the boardrooms in companies like Verizon, AT&T, T-Mobile, Sprint, and on and on and on. And I'm sure in Google and Facebook and Twitter, reasonable network management. What that is it's gray area to allow for a company responsible for these functions to be able to exercise judgment over how the network functions. And the same is true in the body, in my opinion. There has to be some level of priority. For example, how important is the sensation of your arm resting on a table? How important is that to you when compared to your arm resting on a stove that has been turned on for a half an hour? All of a sudden, the priority changes. So we'll continue. 10 orders of magnitude. So we have tens of millions, hundreds of millions, perhaps even trillions of reactions occurring in one cell, and we have many cells in the body. For an enzyme to be functional, it must fold in a precise three-dimensional pattern. A small chain of 150 amino acids makes up an enzyme, must be tested within the cell for 10 to the 12th power different possible configurations per second, taking 10 to the 26 power years to find the right one. This suggests quantum effects at work, even at comparatively large distances within the cell, spanned by a protein molecule. These two examples comprise a very, very, very small degree of the chemical complexity of a human cell. Quantum biology refers to the applications of quantum mechanics and theoretical chemistry to biological objects and problems. Quantum biology uses computations to model biology or biological interactions in light of quantum mechanical effects. The human body is in a constant flux of chemical biological interactions and processes connecting atoms, molecules, cells, organs, and fluids throughout the body and the nervous system. Up until recently, it was thought that all these interactions operated in a linear sequence, passing on information much like a runner passing a baton to the next runner. However, findings in quantum biology have shown that there is a tremendous degree of coherence involving cell communication with electromagnetic waves within all living system. Each human cell may comprise an incredibly complex quantum system. Quantum communication, teleportation, entanglement of quantum mechanics. Complex quantum system as a source of data transfer, both within each cell and among other cells. Each human cell has about 30,000 genes dispersed amongst chromosomes of the cell nucleus. The cellular chemical environment activates or silences genes. Very fast signaling would be required to pass information from DNA that controls all metabolic components in a single cell, as well as to all other cells in the body. Current molecular lock and key models are slow, inflexible, and mechanical. Random collisions of molecules within a cell cannot explain the order and processes. Chemical signaling takes milliseconds to seconds. Ultra-weak light photons may communicate intracellular and extracellular data at the speed of light or greater. It only takes 3 to 4 times 10 to the negative 14 seconds for light to travel the diameter of a typical cell. So that's 3 or 4, right? 10 to the negative 14. So you put a 0, a decimal point, and then 14 zeros, and then you put the 3 there. And then you put seconds after it. 0.00000000000000 3 seconds for light to travel the diameter of a typical cell. So in human speak, right? Layman human speak, we could just say that that's instantaneous right now. What is the human? Freudian slip, that's crazy. What is the command and control center for all this amazing complexity? It must be ultra stable, interactive, and fast. Fundamental biological processes that involve the conversion of energy in quantum form that are usable within the cell, such as light, are quantum mechanical in nature. It's kind of an interesting sentence, right? Fundamental biological processes that involve the conversion of energy in forms that are usable within the cell, such as light, are quantum mechanical in nature. So don't get discouraged or feel like you're lost if you don't understand quantum mechanics. I think that if we were to put a poll out and you were to answer honestly, 1 for you understand quantum mechanics and 2 for no, it will be overwhelmingly 2. And I say that not to point out that we're uneducated in a negative way, but I say that to point out that we are uneducated. This realm of science needs to be explored and understood by the layman, or at least it needs to be quantified and put into forms that are understood by the average person. Because these phenomena more so describe the nuances of life as we understand it that have been unexplainable. And I think a lot of realizations or epiphanies or general understanding would be realized if we had, as a collective, so to speak, a greater understanding of quantum mechanics and quantum science. So I'm optimistic when I saw the $2 billion go out from the White House, right, to go to the energy labs and the universities and whatnot, because hopefully through those endeavors, we will start seeing more open discussion and dialogue about quantum. It's everything at this point. And I say everything I'm exaggerating because nothing really is everything, but I don't want to get too philosophical about nothing being everything and everything being nothing. In my opinion, quantum mechanics are going to be a fundamental underpinning for the future, our future space, because now you can start having pictures of 0 point energy field and quantum communications really occurring person to person without the need for a cell phone. Like complete and total synthetic mind to mind communication, mind to body communication, utilizing the existing principles of nature, electromagnetic fields, light, sound, this idea of resonance, and doing so in a way with such beautiful timing and synchronicity that it actually can be utilized for delicate communication. As we understand a cell phone, as we understand television, hopefully in the near future, so we will understand what quantum networks could provide the species, because it literally opens up opportunities to radically enhance how we communicate, instantly communicate with somebody across the world or maybe even on the moon or Mars, be able to share sensation, be able to share emotion, be able to learn at very, very rapid rates, because the understanding and pinpoint accuracy when you start looking at quantum entanglement and being able to resonate very, very specific things in the body opens the door to a lot of opportunities for personal growth. And the question really is, how are these technologies going to be used? Are they going to enrich and empower us, or are they going to enslave us? Because at what point will communications be indistinguishable from your own internal monologue and or divine inspiration? Quantum effects are counterintuitive, but solves the issue of fast communication within a cell and to all cells in the body. How can cells communicate with each other at a fast enough speed to explain biological observations? Can cells talk to each other, giving precise information to carry out specific functions? Does the DNA within a cell become its command and control center? Is this signaling system like a language that can be learned to redirect cancer cells to stop growing or to stimulate wound healing? The questions could be almost endless. There is abundant experimental evidence showing electromagnetic cell-to-cell communication. Quantum mechanics. Quantum theory and facts are undisputed. By interpreting what it all means is controversial. Bell's theorem experiments established the existence of entanglement, Einstein's spooky action at a distance. In recent years, physicists, philosophers, and computer engineers and biologists have all explored the significance of quantum phenomena. A debate was carried out during the 17th century as to what was light. Isaac Newton believed light consisted of a stream of particles, while Newton's colleague, Christian Huygens, argued that light is a wave. Albert Einstein, Louis de Broglie, and many others postulated and confirmed that photons of light consist of both particles and waves. This is known as the wave-particle duality. Physicists have argued about the correct way of expressing the duality for about a century. In the 1920s, Niels Bohr held that all atomic particles exist in all states until they are observed in specific positions. In the second half of the 18th century, the deterministic character of Newton equations encouraged many people to see the physical world in strictly mechanical terms, as if the universe is a gigantic piece of a cosmic clockwork. 20th century physicists saw the death of this merely mechanical picture through the discovery of intrinsic unpredictabilities found in quantum theory. Quantum mechanics provides a concrete model of nature that is comparable in its essence to Newton's laws of motion, Maxwell's theories of electricity and magnetism, and Einstein's theory of relativity. In 1905, Einstein proposed a new quantum theory based on the photoelectric effect that was first earlier introduced by Planck. Einstein said that ionizing radiation is not uniformly absorbed, but is a series of local collisions, each with sufficient energy to ionize an atom or break a chemical bond. In 1909, Einstein said, "A fundamental change of our concepts of the essence and constitution of light is indispensable." Einstein imagined energy quanta, today light quanta or photons. So Einstein imagined photons that move without being split and which can be generated and absorbed only as a whole. This new concept was used to understand photoluminescence, the photoelectric effect and ionization of gases with UV light. Einstein believed that an energy quantum of the light generated can obtain its energy from several generating quanta or photons. Einstein's views were intuitive and paradoxical, understandable and inconceivable. Light photons appear to have a split personality, being neither a wave nor a particle, since quantum mechanics accomplishes a formal synthesis. These are difficult to understand in the case of light because of crazy things that occur in the world of atoms, which also occur on a macroscopic scale. Light quanta were called photons by Gilbert Lewis in 1926. Max Planck had earlier argued about the role of little packets of energy. This would explain jumps of quanta for orbital electrons, the photoelectric effect, and eventually for radioactivity. Bohr's correspondence principle stated that quantum theory of the atom ought to match seamlessly with classical analysis of atomic behavior, since both quantum and classical behavior tend to have the same outcome. Many state only things that could be mathematically proven. Quantum theory needs imagination, since it is difficult to describe in familiar language. And I think that that last statement is true for most of us, even myself. To allow your mind to imagine when trying to absorb these concepts, right, is probably the most important thing. To allow your mind to imagine when you are trying to absorb these concepts. Because what is being attempted to be described by those that are experts in the quantum fields means that there needs to be new language and new concepts and new definition for those discovered concepts to be generated. And that happens much, much sooner than it trickles down to us. Because we don't study that stuff at that level of detail to be able to utilize existing words, language, concepts to try to explain and understand something that is new, something that is unexplainable, to then over a course of time, through collaboration amongst fellows that look at the same type of things, in this case, quantum science, to be able to generate and create a new language, new concepts, and stabilize and standardize and prove out theories and theorems, which then trickle down to other applied sciences, if you will, or other applied technologies that utilize these principles. And through that trickle down effect, that's how ultimately we understand things. Because we generally go to school, we learn something specific, and then we go perform a job. And that's our existence here. And if concepts aren't introduced to us in school or at our job, we generally don't have knowledge of it. And so it seems complicated and difficult to understand, when the reality is most of it's not. Some of it is, but most of it's not. And it just takes time and effort to learn. And then all of a sudden, things aren't necessarily as complicated anymore. And I am by no stretch saying that quantum mechanics is that. I don't think that we're there yet, even as a species. Even the best and the brightest, I don't think, understand it well enough to say that it's a simple thing. And I think to support what I just said, there's a reason why $2 billion over the next, 2 billion with a B, over the next few years are going to be applied towards non-military research in the United States for quantum sciences and AI. It's for that reason, because we don't really understand what we need to understand to start standardizing, normalizing these phenomena. So the money, I think, is to spread around knowledge, and through the effort of spreading around knowledge of quantum science and AI, build up the general knowledge base, which will then trickle down to everyone else. So I think it's kind of being used to jumpstart that whole process. Next paragraph. Erwin Schrödinger and Werner Heisenberg birthed quantum mechanics by examining the wave-particle paradox, or the duality of light. A quantum field exhibits both discrete quantized particles, particle-like behavior, and spread-out properties, wave-like properties. To Heisenberg, this is what the atom looked like: a fuzz of energy concentrated in the center, where a precise location and momentum could not be both known at the same time. So what they're saying is that you can either know the location and not understand the momentum, or you can know the momentum and not understand or know the precise location, but you cannot know those things at the same time. Heisenberg's uncertainty principle states that quantum particles do not occupy a fixed measurable position. Measurement is everything. Measurement is everything in quantum mechanics. Heisenberg believed that if you knew at one moment the precise location and time and space of every particle in the universe, you could predict the future. You would be as omniscient as God. This is, of course, a divine prerogative, and according to Einstein, none of our business. However, for God, there is no uncertainty. The solution for Bohr was to accept the different and mutually exclusive results of light waves and particles as equally valid, and stand them side by side to build up a composite picture of the atom. These exclusive abstractions complemented each other, but could not be resolved or merged. Bohr attempted to close the gap between life existence and quantum existence. He felt that biological laws must be consistent with physical and chemical laws. Quantum theory implies a counterintuitive togetherness in separation. Let that one sink in, right? Quantum theory implies a counterintuitive togetherness in separation. That sounds like a Democrat slogan for COVID. Anyway, so togetherness and separation, by which two quantum entities that had interacted with each other retained a degree of instantaneous mutual influence. So, two quantum entities that had interacted with each other retained some influence from one another, no matter how far away they get. That's quantum entanglement. So two things that are quantum. The easiest way to look at that would be photons or electrons, right? They interact with each other, and no matter where they go, right? No matter where they go, they always have a relationship with each other, no matter how far away they are. Sounds like a love story, a quantum love story. Two quantum entities intertwined are separated. No matter how far away they are, they still have some connection and some influence to each other. Doesn't matter how far across the universe they traverse, through any space or any time, they still are able to influence one another. Quantum love story, quantum entanglement. Quantum particles travel through space in waves that spread out and that can be in many places at the same time. Interesting. I'm going to read that again. Quantum particles travel through space in waves that spread out and that can be in many places at the same time. And what are the implications of that? To be in many places at the same time. What if you were able to measure that without disrupting it? Things that make you go, Two quantum particles or waves can interact at a distance in a way that may seem telepathic. Telepathic. Very important paragraph in my view, right? This quantum love story, quantum particles traveling through space, waves that spread out, they can be in many places at one time, but still are able to mutually influence each other no matter the distance in time or space. They can interact with each other at a distance in a way that may seem telepathic. Quantum theory is supposed to describe the behavior of elementary particles, atoms, molecules, and every other form of matter in the universe. Quantum theory attempts to explain the intrinsic reality of atoms in statistical terms, meaning not definitive. Those of you that are familiar with statistics know that statistics can tell you completely opposite stories using the same set of data. Just look at the COVID analysis. So, quantum theory is supposed to describe the behavior of elementary particles, atoms, and molecules, and every other form of matter in the universe. It attempts to explain the intrinsic reality of atoms in statistical terms, using analogies and metaphors. Doesn't sound much like science, does it? And what it really is trying to say here, in my opinion, is this idea of probabilities, that matter or energy, we'll just say energy, is everything and it's nothing at the same time. And only when that energy is observed or measured does it become something definitive, put into our reality. Crazy concept to think that everything is nothing, that everything is infinite and everything is finite at the same time, and that we don't know until we observe it. And at that moment, it becomes something tangible, something that we can look at or sense or feel. It does not follow classical rules in physics. Every part of quantum mechanics seems to violate some cherished notion that we cling to. Quantum mechanics changes the rules. What are the kinds of relationships between waves and particles? You've always got waves. You've always got particles. Advances in quantum mechanics, which are linked to nuclear processes, have revealed strong and mysterious forces and effects. Schrödinger envisioned a cat placed in a box and potentially killed by poison that is simultaneously dead and alive until someone opens the box and peeks inside. Such also is found in quantum mechanics, where an atom can be in two states at the same time. It is very hard to see how one might make sense of any of these disciplines, let alone see any unifying picture that underlies them all and explains their deep interrelations and mutual dependence. The reality problem is not solvable within quantum theory as it stands. This was written in 2017, folks. This was written in 2017, folks. And so, along with the variables that describe potentialities and possibilities, we need to supplement our quantum equations with quantities that correspond directly to real events or things, real stuff in the world. Bohr said, everything we call real is made of things that cannot be regarded as real. For example, spontaneous disintegrations of A and B particles and some wavelength of rays and conversion electrons from radioactive atoms occur at a predictable rate, statistical probability. Radioactive decay is stochastic, which means random, and isotropic in all directions without bias, at the level of a single atom. According to quantum theory, it is impossible to predict when a particular atom will decay, regardless of how long the atom has existed. For a population of like atoms, the decay rate and physical half-life can be calculated without any special hypothesis. Each radioactive atom in a population of like atoms appears programmed within it a statistical probability for disintegration. In addition to the mathematical quantities given to us by quantum theory, we also have questions, we also have equations defining a definite path through space and time for each elementary particle in nature. Quantum mechanics' great achievement was to show that we can find a mathematically consistent description of reality alongside quantum theory. Theoretical physicists are happy to exploit the opportunities provided by the fact of deep and beautiful intelligibility, but simply as physicists, they are unable to explain why this is the case. A religious perspective on the physical world, understanding it to be a divine creation, can offer the insight that deep cosmic rationality is an indication that the mind of the creator lies behind its wonderful order, and our access to it reflects the fact that we are creatures made in the image of our Creator. Here's an interesting diagram. Quantum mechanics, probabilities, probabilistic, wave-particle duality. Things function as a particle and at a wave. Uncertainty exists because of probability, and it's energies rather than forces. Quantum mechanics, discrete quantities, quanta or photons, just being a singular form of energy, explains the nature and behavior of matter and energy at the atomic and subatomic levels. Properties of light. So, for those of you that are still here, I'm glad. Please stay. There is a method to this madness. When we get further down in this document, they're going to cite some very interesting scientific phenomena that will shock you. It shocked me. It literally reshaped some of my perceptions, so to speak. So what we don't get to today, we will get to Friday morning on East Coast time, US. But please stick around, because I firmly believe that this idea of quantum is our next major jump. There's going to be something else. There will be something else after quantum. There always is something else, right? But this is the next jump. Photons. Photons are conceived as localized energy packets. A light beam can be viewed as a stream of photons. Radiation originates from individually independent processes during which a single photon, an energy packet of a magnitude, right? And they talk about the formula. They actually define it down. Planck's constant is velocity, and magnitude looks like HV, which doesn't really matter. So a photon is emitted. It is possible to speak of an individual photon only when a single atom is its generator. Propagation processes can be described only with the aid of wave theory. A photon has energetic indivisibility. Its energy cannot be arbitrarily diluted. Either we find a photon or we do not. Light particles also have no rest mass, and thus can travel at the speed of light or even faster. The momentum of the photon is experienced by the medium in which it is absorbed or reflected. Photon momentum is noticeable only in absorption and in the process of spontaneous emission. One cannot observe in the same experiment both atomic recoil, particle nature of light, and interference, wave nature of light. The photon possesses angular momentum known as spin that is closely related to linear or circular polarization of light. The spin of a photon is transferred to the absorbing medium. Light waves can be generated in an optical resonator that confines and stores light of certain resonant frequencies. Light can be repeatedly reflected in a system that is used for biosensing. In optical physics, two wave sources are perfectly coherent if they have a constant phase difference and the same frequency. Coherence describes all properties of the correlation between physical quantities of a single wave or a wave packet. Coherence in physics and quantum physics is an ideal property of waves that gives the wave very stable intensity and the potential to very accurately transmit information. Squeezed light exhibits a coherent state. Processes associated with nonlinear optics in biological systems are best suited for the generation of squeezed light. Squeezed coherent light, photon, has a close connection to Heisenberg's uncertainty principle. The amplitude of squeezed light has a narrower photon number distribution than one of a coherent state of the same amplitude, resulting in a minimum quantum noise and improvement of signal-to-noise ratio. Squeezed coherent states may use multiple wave mixing. The squeezed state is used for quantum information processing for continuous variable systems, such as for quantum communication, quantum teleportation, and one-way quantum computing. Squeezed light finds application in teleportation, teleport from one beam of light to another. Parametric in optical physics is any process in which an interaction occurs between light and matter that does not change the state of the material, such as the components of a human cell. That's a lot right there. There's a lot in that paragraph. That's one of the paragraphs that you have to read like 3 or 4 times to really kind of understand what's going on there. But basically, they're defining light, and they're saying squeeze light. It's a particular method of transmitting it or generating it, is what biology basically uses, and that because of the properties of squeeze light, it reduces interference in the communication. It cleans up the signal. It cleans up the light so you don't have as much interference. So when you use it for communication, it's a better mechanism to send information from one place to another using squeezed light. And they say it's good for information processing for what they say continuous variable system. So that's what the body is, continuous variable system. Everything constantly changing, right? All of those chemical reactions, just the chemical reactions, not the electromagnetic emissions, not the quantum communications, just the chemical reactions are in the hundreds of billions with enzymatic activity, possibly even trillions in a single cell. So that would very easy to see that is a variable system. And they're also talking about squeeze light being used for quantum communication. Well, what you're going to see with quantum communication, you're going to see a lot coming out that has to do with fiber optics, because fiber optics send light. And they will use what they call dark fiber to set up quantum networks that really utilize the public fiber optic network. And it's not exclusive to dark fiber. They can use live active fibers for quantum communication. It has to do with how the light is generated and how it's transmitted. Wavelength, meaning the frequency, the amplitude, how much power, polarization, and then sending multiple photons in unique ways that have a relationship with each other. So you get 4, 5, 6, or 7 different streams, if you will, traveling down a fiber optic cable that have to be received at the other end in just the right sequence, with just the right wavelength, with just the right power, and just the right polarization. When you think of a circle 360 degrees, if you have to track for one blip of a communication 4, 5, or 6 or more, maybe even up to 8, who knows how many, right? Different streams that all have to be received at just the right time with just the right wave characteristics for it to be able to pass the encryption decryption process, where you achieve entanglement over a fiber optic network. It's sent, it's received. It could be 50 miles away, it could be 5,000 miles away, with repeaters in the middle, regenerators in the middle, that are able to understand wave characteristics, light wave characteristics, with such specificity and such detail that you can generate encryption mechanisms that if there is something as simple as a bad splice in the fiber optic cable. Think about it, 50 miles of cable. It's not going to be one piece of cable. It's going to be many different pieces of cable that have been what they call fusion spliced together, where they literally open up the fiber optic cables, they lay out each independent fiber, they strip off the outside cladding, which keeps the light wave inside. There's a reflective cladding that goes over top of silica, fiber optic glass, very hair-like, couple microns, 5-7 microns thick piece of glass that is super purified. So there's very little, if any, defects in the glass, and they stretch it out to be as thin as a hair. And then they insulate the outside of it and they color code it. And they typically come in ribbons of 12, and they have various color schemes. Blue, orange, green, brown, red, slate, and then the secondary colors, white, yellow, black, red, violet. And then you have rose and aqua. And those are your 12 fibers. Maybe not necessarily in that order. I've been out of the fiber splicing practice for a long time now. But they'll open them up, they'll expose the bare glass, and then they literally arc weld them together. They use a computer to do it. There's an expensive machine. They've come down in price now, but you literally put these things into specific handlers that then use a computer and mirrors and cameras to line up the glass, the hair-like fibers, to line them up, and then they energize 2 electrodes and they melt them together. And when they're done, the melt is next to nearly the same purity as the manufactured glass. And the reason it's important to have that purity or that cleanliness or that perfect splice, if you will, or a near perfect splice, is so that you don't get loss. Number one, you don't get power loss, light level loss. But when we're talking about quantum communications, any distortion in the glass could disrupt a quantum communication. As a result of that, a quantum network will need to be tested so that each leg of the network will be known, so that you test the fiber optics and you understand what the imperfections are in the cable, 50 miles or more per segment. You need to understand what the imperfections are and where the imperfections are, because that will impact how the light waves travel along that fiber. And if you're trying to track multiple photons that are doing very specific things that all have some order to them in order to create quantum encryption, imperfections are going to disrupt and destroy that. And the imperfections may affect some wavelengths differently than they affect others. Anyway, here's your fiber splicing lesson for the day. Light photons, entangled in energy and time, are not limited to the microscopic, atomic, or molecular. They're not limited to those dimensions, but can extend over macroscopic distances. Quantum entanglement is a physical phenomenon that occurs when pairs of laser light photons, particles, are generated or interact in ways such that the quantum state of each particle cannot be described independently of the others when the particles are separated by a large distance. Instead, a quantum state must be described for the system as a whole. It appears that one particle of an entangled pair knows what the measurement has been performed on the other pair, or the part of the pair, and with what outcome, even though there is no known means for such information to be communicated between the particles, which at the time of measurement may be separated by arbitrarily large distances. So what is that saying? What that's saying is that you can generate a photon or a pair of photons. You can send one far away. You can then measure one of those two and then look at its partner, its pair, and understand what you measured. So you can generate 2 photons, one stays where you are, you send one down a fiber optic cable, and it gets to its destination. you measure the photon that you kept where you generated it, right? Because of quantum entanglement, you then get to define what the other photon is, even though it's traveled potentially thousands of miles away. That's crazy to try to imagine that that's even possible. You generate 2 photons, they're linked. Keep one, send one. You manipulate the one that you keep. And that manipulation instantly has an effect on the one that's sent. And to think that humans can do this in bulk, many of them simultaneously, and track them, and then use that for communication is freaking remarkable. Measure how? They're measuring the spin state. Typically, a simple way to look at it would be an upspin or a downspin, even though there are other spin states. The easiest way to really understand it is that you have an up or a down. And an even easier way to apply that to digital is up is a 1 and down is a 0, even though it's way more complicated than that. Because when you think about probabilities, you can have a spin in any orientation and have that have some assignment of probability. What percentage of time will that spin angle result in an upspin or a downspin? And you can create probabilities that way. It's super, super crazy science, which is why the best I can do is tell you it's super crazy science, right? Because some of the concepts, and this is a basic 101 concept, which just further explains how little we generally understand of quantum. And those that do understand are grappling with the idea or the necessity of trying to define what it is they're even looking at, and then trying to associate concepts or ideas and terminology and language to then be able to communicate as we fundamentally do, right? Using language, developing a language for the concepts to then begin to have dialogue to try to understand what the hell is going on. Yet we're throwing $2 billion at it and we're building quantum networks that really is 5G right now. So you folks out there, tell me, do you really think that they have most of this already figured out? And do you think that they're just dripping it out slowly so that as academia and as the public-facing national laboratories make the breakthrough discoveries that we can kind of be brought along? That's what I think. I think that the 2 billion is like throwing a bunch of energy, no pun intended, because the money mostly is going to the Department of Energy, at quantum sciences and artificial intelligence to speed up the disclosure process, whereby the 2 billion then provides cover, so to speak, and or resources to begin to reverse engineer or reconstruct or create duplicates or triplicates of existing systems. And what I'm hoping is happening is that the United States in particular, I'm partial, I'm a US citizen, that the United States are building multiple systems that interface in the quantum space, whether it be for information exchange or for science or for sensing or for interdimensional activity, so that the technology is diversified, so that those that misuse the technology can be cut out and dealt with, and we don't disrupt things like national security. We don't disrupt things like whatever the hell is really going on. Trump 2020, motherfucker. Let's continue. So, quantum entanglement, a physical phenomenon that occurs when a pair of laser light photons are generated or interact in such ways that the quantum state of each particle cannot be described independently of others, even when the particles are separated by a large distance. Instead, a quantum state must be described for the system as a whole. It appears that one particle of an entangled pair knows what the measurement has been performed on the other particle, and with what the outcome of that measurement is, even though there is no known means for such information to be communicated between the particles, which at the time of measurement may be separated by arbitrarily large distances. Forever. Forever, ever? Forever, ever. Einstein called this phenomena spooky. Space and time may result from the quantum entanglement of qubits, which provide an underlying informational code for the universe. Qubits, an underlying informational code for the universe. The counterintuitive predictions of quantum mechanics have been verified experimentally. This has been shown to occur even when the measurements are performed more quickly than light could travel between the sites of measurement. I'm going to read that sentence again. It's kind of important. The counterintuitive predictions of quantum mechanics have been verified experimentally. This has been shown to occur, right? Even when the measurements are performed more quickly than light could travel between the sites of measurement. So we're talking about entangled photons that can be in two different places, and these places can be thousands of miles apart. And they take measurements and they find these known relationships. When I say known, they're just repeatedly observed. And when they're repeatedly observed, you get the same results. And that these measurements are taken, and with the clock timing that they're able to achieve, they are able to calculate that these measurements occurred faster than light could travel between the two locations, thereby, to some extent, proving the spooky action at a distance, right? Quantum entanglement. No matter how far apart, two star-crossed photons still can interact with each other. Quantum love story that is quantum entanglement. Recent experiments have measured entangled particles within less than 1/100% of the travel time of light between them. 1/100% of the time it takes for light to travel between the two of them. There's a lot to be said, right, about that. Number one, it's pretty cool that generate two photons, separate them, measure one, know the outcome of the other, and this can be done faster than the speed of light. And now they're saying that recent experiments have shown that this can be done, the measurement, which only defines the limitation of the equipment that humans have built to measure, is 1/100% of the time it takes for light to travel from A to B. What does that say about the sensitivity of our measuring instruments? If they can say with certainty that they're taking measurements and they can validate that these measurements are occurring faster than 1/100th of the percent of time it takes light to travel between the two locations. How sensitive do you think those measuring instruments are? That's ridiculously sensitive. According to the formalism of quantum theory, the effect of measurement happens instantaneously. Quantum entanglement is an area of extremely active research by the physics community, and its effects have been demonstrated experimentally with photons, neutrinos, and electrons. Research is also focused on the utilization of entanglement effects in quantum communication and computation. Quantum theory predicts that electrons in an element's atom should line up facing the same direction. This is not what chemists saw when studying element 97, berkelium. BK electrons had unaligned orientations, which were the result of them becoming heavier at higher velocities. This was not the result of quantum mechanics, as is normally observed, but rather Einstein's theory of relativity. The faster something with mass moves, the heavier it gets. Some may term this relativistic quantum mechanics. If this can happen with BK and possibly other transuranic elements, then why can it not happen to the cell? Teleportation. The quantum state of atoms have been successfully beamed from one spot to another as far as several miles away. This is a promising discovery for computing, known as quantum computing. Information transfer has a significant role in quantum physics, and that role seems to go beyond classical physics. The quantum state that is being teleported is nothing other than information. Space and time in Einstein's relativity are unified as space-time, in particular, quantum non-locality teleportation. Within the framework of concepts introduced by Einstein, Podolsky, and Rosen, the notion of information and reality may also be unified in quantum communication. This is profound if it's true. I almost want to read it again, but it's a lot to take in. So I'm glad you're still here. There's a lot to take in. The quantum state that is being teleported, we're talking about teleportation, is nothing other than information. Space and time in Einstein's relativity are unified as space-time, in particular quantum non-locality or teleportation within the framework of concepts introduced by Einstein, Podolsky, and Rosen. The notion of information and reality may also be unified in quantum communication. So the quantum state being teleported, we're talking about teleportation, is information. And what they're saying is that information and reality may also be unified in quantum communication. So is that a roundabout way of saying that reality can then be teleported? What does that mean to you? Tell you what, my mind's going crazy right now, trying to figure out the implications of that. And I don't mean crazy like crazy, but it's like my brain is cooking, trying to wrap my mind around what I just read. This idea that information and reality can be unified in quantum communication, and that further up it says that a quantum state that is being teleported is nothing other than information. So now we're unifying information and reality, because reality is information. It has to be defined, and through that defining process then thus becomes information. And now we're looking at this concept of being able to teleport information. Whoa. Anyway, quantum teleportation, the transmission and reconstruction over arbitrary, meaning any, distance of the state of a quantum system is demonstrated experimentally. During teleportation, an initial photon, which carries the polarization that is to be transferred, and one of a pair of entangled photons are subjected to a measurement. So one of a pair of photons are measured, and they understand the polarization when they measure it, such that the second photon, right, the pair of the entangled pair, acquires the polarization of the initial photon. So quantum entanglement, two photons, one goes away. It could go anywhere. You measure the one that you keep, and you understand that its polarization is top to bottom instead of left to right. And that instantly makes that photon that you sent away, that it's entangled with, also become top to bottom. And you gotta, how's that possible? What does this even mean? During teleportation, an initial photon, which carries the polarization, up or down, left or right, just to keep it simplified, that is to be transferred, and one of a pair of entangled photons are subjected to a measurement. One of the two are measured, such that the other one of the entangled pair acquires the same polarization, up or down versus left or right, of the initial photon, the one that you measured. This latter photon can be arbitrarily far away, anywhere away from the initial one, the one that you measured. Quantum teleportation will be a critical ingredient for quantum computation networks. The qubit is a computing quantum bit, or a unit of a smallest possible amount of quantum information. In quantum mechanics, the qubit is a superimposition of vertical and horizontal polarization of a single photon at the same time. So a qubit is up and down and left and right at the same time. Superimposition. Superposition of two states at the same time is fundamental to quantum computing. Quantum information processing with single photons or photo pairs as qubits are all intimately related to quantum entanglement. The qubit is a way of compressing states emitted by a quantum source of information. Multiple qubits can exhibit quantum entanglement that processes information more efficiently than on a classical computer, where bits only have one value at a time. The technology can be used to produce a holographic memory qubit for quantum data storage. Quantum entanglement and teleportation are unique to quantum computing. Teleportation means transportation of things from one place to another. Relativity theory teaches us that the velocity of light is the upper limit for motion of an object. According to quantum theory, the quantum mechanical wave function represents the maximum information known about the object. Teleported photons disappear and reappear almost instantaneously at its destination. Teleported photons disappear and reappear almost instantaneously at its destination. Quantum mechanics offers magical tricks. The transmission of the wave function that needs to be successful requires two systems must be entangled. The vehicle of teleportation is the entangled pair. Quantum teleportation is feasible in the case of continuous variables, identifying both position and momentum. Interesting. Teleportation can be achieved between photons, atoms, molecules, and even different states of atoms, meaning ions. Quantum states can have a long life. Teleportation is the perfect way to transfer quantum information from the output of one place to the input of another. One-way quantum computers are also possible. Coherent light from lasers produce a special kind of light in the form of peculiar pairs of photons that are quantum entangled, intimately connected. Quantum love story. When one is measured, the state of the other one is instantly influenced, no matter how far apart they are separated. Two particles of light that collide with each other are still intimately connected. Quantum entanglement has philosophical and theological implications. Quantum entanglement works across a distance in terms of traveling signals that are faster than the speed of light. Entanglement can be used to circumvent the limitations imposed by Heisenberg's uncertainty principle without violating it, and open a way to teleportation. Thus, the human cell may transmit information among all other cells in the human body using quantum teleportation. Numerous studies have been published during the past 95 years showing evidence of electromagnetic cell-to-cell communication. A shift in focus to biochemistry after World War II greatly slowed down further research interest in cellular communication. An interest in earlier dish-to-dish studies of physically disconnected cell cultures returned during the 1970s and continues with increasing awareness today. I'll read that again. Interest in earlier dish-to-dish studies of physically disconnected cell cultures returned to prominence in the 70s and continues observation experimentation with increasing awareness today. So 2 Petri dishes, they're in their own enclosures, side by side, but they are in their own enclosures, perhaps some distance away. And this idea that you can introduce stimuli to one of the dishes and observe a change in the other dish that is repeatable based on the type of stimuli you apply to the first dish. So it's this idea of quantum teleportation, quantum entanglement with biology. We have 20 minutes left and we're going to start getting into the good stuff. So you'll know where we're going to be at in a few more days. Should you choose to read forward, please do so. But if not, Friday morning. Alexander Gavrilovich Gurevich, a famous Russian embryologist, I think, physician and professor of histology in the 1920s, discovered ultra-weak, ultraviolet photon emissions from living tissue. He named these photon emissions mitogenetic rays because they stimulated an increase in cell division, mitosis, even from nearby unexposed cells. Gurevich devised what he called the basic experiment. Normal window glass blocks ultraviolet rays, while quartz glass is transparent for UV light at 260 nanometers. 2 onion roots were arranged at right angles to one another, with the horizontal root pointed towards the vertical stem, with a space for either normal window glass or quartz glass plate. The subject of observation was cell mitosis rate on the stem, where the root tip was pointed. When window glass was placed in the space between the root and the stem, no cell division changes were noted, whereas when quartz glass was placed in the space, cell division increased significantly by 30%. Gurevich concluded that ultra-weak, Ultraviolet photon emissions in the horizontal root were stimulating increased cell division in the vertical stem. The data suggested that photons might regulate cell growth and differentiation. Natural gamma radiation may serve in part as a suitable or substitute, for sunlight by stimulation of photosynthesis in algae-denied natural sunlight. A UV photon emission are also associated with the exposure of cells to low LET radiation. In the ensuing age of biochemistry, molecular biology, and hormones, Gurwich's studies were largely forgotten. Dr. Vlil Kazanyev was director of the Institute for Clinical and Experimental Medicine in Novosibirsk, USSR. Guided by Gurwich's work, he carried out thousands of experiments over a 20-year period in the Soviet Union, which were published in a book in 1981. They indicated that cellular information can be transmitted electromagnetically in target cells, absorbing photon radiation from damaged cells. Kazanich had demonstrated optical coupling between two sealed quartz cell structures. Optical coupling between two sealed quartz cell structures. In the basic experiment, two sealed quartz containers contained the same cell culture, were separated by a thin optical quartz window. One sample was equally divided and placed in each of the two halves of the apparatus. Thus, the two containers were completely and environmentally shielded except for optical coupling. The cells in one sample were subjected to ionizing radiation. This usually led to the death of cells in the exposed culture. Kazanich's observations were unexpected and counterintuitive. If the window was made of ordinary window glass, the untreated cells on the other side of the window were undamaged and remained healthy. This was as expected from Gurwich's studies. However, if the window was made of quartz, then cell death appeared after about 12 hours in the unirradiated sample. From 70 to 80% of the tests demonstrated this optical coupling. Cells in the irradiated culture were thought to give off photons in the near ultraviolet region when they died. The quartz window was transparent to the UV death photons, which were absorbed in the unirradiated culture on the other side of the window. The same type of responses were also observed for cells treated with microbiological and chemical agents. The detection of ultra-weak light photons within and between cells is difficult because of possible light noise from many potential sources, such as reactive oxygen species, enzyme catalysts, and phosphorescence. The Japanese manufacturer of optical devices, Hamamatsu Photonics, developed a photomultiplier tube which was able to accurately measure and count single ultra-weak photons, the typical observed photon density in biological tissues. In the visible and ultraviolet region was approximately 1 to 1,000 photons per centimeter squared per second. Using the system, the light intensity was detectable above the background of thermal radiation emitted by the tissues at their normal temperature. Just think about the sensitivity of these measuring tools, folks. It's pretty remarkable. Fritz Albert Popp A German biophysicist and cancer radiotherapist discovered a wider spectrum of ultra-weak photon emissions from 200 to 800 nanometer, common from living cells. He coined the term bio-photon for these photons of very weak light. According to Pop, a bio-photon, coming from the Greek meaning bio, right, life, and something else in Greek, I'm assuming photon, right, meaning light, is a photon of non-thermal origin in the visible and ultraviolet spectrum emitted from a biological system. The typical observed radiant emittance of a biophoton in biological tissues in the visible and ultraviolet frequencies range from 10 to the negative 19 to 10 to the negative 16 watts per centimeter. So 0, decimal point, 19 more zeros after the decimal point, and then a 1. Watts per centimeter. So they're actually able to measure the power that is emitted from the photons that come out of a cell or biological tissue. This light intensity is much weaker than that seen in the perceptually visible and well-researched phenomena of normal bioluminescence, but is detectable above the background of thermal radiation emitted by tissues at their normal temperature. Lower energy photons, longer wavelengths, not detected by the human eye, can be detected by special detectors. Low energy thermal photons abound in the cell. These energies are so tiny compared to room temperature thermal energy that it is very difficult to separate them as quantized entities. Their presence literally swamps the cell with background energies. The thermal energy of a molecule at room temperature is about 0.04 electron volts. Thermal energy of a molecule at room temperature, 0.04 electron volts. Mammalian cells have a metabolic rate of about 30 times 10 to the negative 12 watts per cell. The combined heat of 33,000 normal cells is detectable if instrument sensitivity is at least 1 microwatt. A comprehensive review of the field of biophotons is provided by Ted Nissen. Biophotons represent a more subtly complex cell-to-cell communication that relies upon speed of light transmission for communication. Pop found that biophotons were coherent and may regulate all life processes of an organism. This is a very small number and is why biophoton research is so controversial. Mammalian tumor cells emit photons at rates as high as 1,400 per square centimeter per minute, compared to healthy tissues that average rates of less than 40. So here's wavelength, a little wavelength chart, just to show you. The AM radio band, you're down to 10 to the negative 9. Shortwave, 10 to the negative 8. TV and FM radio, 10 to the negative 6. These are energies. Yeah, that's what these are. These are electron volts. So they're not wavelengths, they're actually the amount of power in one cycle. That's what these are. Quantum energy, yeah. Quantum energy of the electromagnetic spectrum in electron volts. When we get to it, we're going to go over a NASA document on electromagnetic effects on the human organism, and they go over this in detail as well. We're getting to the electromagnetic piece here sometime soon. So cancer, 1,400 per square centimeter versus healthy tissue at 40. per square centimeter. Biophotons may even signal malignancy in tissue before more conventional imaging. Biophoton energies appear to spread from infrared to ultraviolet. These are wavelengths in the electromagnetic spectrum, folks. Albrecht Buehler spent 30 years researching possible data processing of infrared signals. 3T3 cells were found to extend their pseudopodia toward single or paired infrared sources, particularly in the 800 to 900 nanometer wavelengths. Guess what wavelengths the iPhone face recognition, LED lasers, and photodiode emit and receive at? Take a wild guess what bandwidth that thing uses. I'll give you a little hint. It's in this range right here. This range right here. Things that make you go, 30 to 60 pulses per minute. 3T3 cell emits infrared light within the range of wavelength 800 to 900 nanometers, which is what your iPhone emits, at 30 to 60 pulses per minute, the 3T3 cell. Temperatures change. Temperature changes were negligible, and chemotaxis were both ruled out as being involved. Cells seem to see objects, suggesting that cytoplasm has certain capacity of data processing and integration. In other words, cells seem to exhibit intelligence. We'll stop here because we're going to get into DNA in a few days, but I want to show you something. I want to show you. Let's go here first. I want to show you this. It's going to take a minute for me to get there. Let this thing catch up. And I want to take you to a document that is associated in this thread that I have. And it talks about nanoscale communications. This is the one right here. Nano networks, folks. Nano networks, a new communication paradigm. Georgia Institute of Technology. This was back in 2012, and they talk about nanotech, the synthetic versions. Here's a nice graph. The design of nano machines, biohybrid versus nanomaterial based. So nanomaterial based, you have graphene, carbon, zinc, all nanotubes, nanowires, gold, nanoparticles. You have nano batteries, nano memories, nano transistors, nanoelectronics. Charles Lieber has a patent for that. And then you have the biological side, the biohybrid, DNA, organelles, mitochondria, biotechnology, cells and bacteria, hormones, proteins, cellular type communications. And we may spend time going through this again. This is a great document, by the way. Human Internet 1 on Twitter. Click the pinned tweet and go down and you'll see this nano network document. And what I want to show you here is twofold. This idea of advanced health monitoring, whereby nano networks are in the body, whether they're introduced synthetically or they just tap into your own cellular nano networks, brain, heart, limbs, joints, organs, with an exterior interior interface, right? Something like a watch or a phone or a headphone, or maybe some chip, some quantum dot interface that works off resonance, nanotech that interacts with other things that have nano network tech in it. Terabit links, basically links over light, and or terahertz radiation, which is an emission from 5G, as well as others. As you can see, this is all communication and comms set up to the people from light poles, from the walls in the building, etc. This was back in 2012 when Georgia Tech, who works with DARPA a lot, was putting this stuff out. Sensors everywhere, nano projectors, nano phones, nano cameras, bio-inspired designs of nano processors and nano chips. And here we go. This is the important piece. A future look. The silicon technology era is coming to an end circa 2020 to 2030. So now, right? Now. And what is happening is molecular technology area is starting and will be dominating our lives for the next 80 years, circa 2020 onwards, meaning now. 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 Different approach to nanomachines, biology, life. Cells are nanoscale, precise biological machines. They communicate and interact and cooperate. A cell as a biological nanomachine. Molecular transmitters, biological memory and processor, the nucleus and ribosome. Mitochondria is a biological battery. Chemical receptors, biological sensors, molecular receivers, and a flagellum, biological actuator. One example of a biological machine. Biological nanomachines, a biological battery, mitochondria, glucose, amino acids, fatty acids, oxygen. There's your ATP, adenosine triphosphate, where we were talking about those things that are cycled 15 million times or something like that. Biological memory, DNA, amino acids, ribosomes, the genetic code, genetic software, folks. The instructions for life. Biologic communication through hormones, proteins, and ion transfers. Example of a transmitter: synthesizes and releases molecules, proteins in the medium. This is just one example. Chemical transmission. This is very slow communication relative to the light or quantum or electromagnetic. Electromagnetic technically is light, so chemicals or ions or proteins are released, and then they find their appropriate receptor site, and all of this can be tracked in the body. And it can be tracked in the body, and it can be put on a network, right? Because AT&T has patented the ability to address your brain, your body, and your cells on the internet. AT&T describes the ability to use a person's brain or thoughts to control aspects of another person over the internet, such as their thoughts, motor movements, and control. And if you don't believe me, go to human Internet 1, and look at this patent and read about it, because this is what is going down. Whether you want to go on the ride or not, it's happening.
I like how you end all your shows. You're like, okay, that's it. Bye. There's a lot of quantum talk, quantum entanglement, a lot of teleporting talk too.
It's one of my favorite words.
That. I that's what you said.
Yep. One of my favorite words.
What was the other one?
Radar.
Oh, radar.
Mm-hmm.
Gotcha.
Which a long time ago, we went over the quantum satellite patent that discussed using wireless technologies for quantum encryption key distribution. So we looked at we talked about fiber optic quantum communication a little bit, but it also applies to the wireless network. We're not quite there yet. We're going to get there. Don't worry.
So that's why you had to whisper, right? Because we're not quite there yet.
Yeah, well, it's this stuff is creepy cool. So
No, it is
it's an
actually
oxymoron in my view, but it's going to be a wild ride, man. That's for sure. All I got to say is get your mind right and understand what is important to you. And if you don't have faith, or if you don't have a solid foundation by which you base your decisions, look the fuck out, because you will be in for a rude awakening. So as long as you are steadfast in your belief system, if you have a strong infrastructure in your soul, then I think you have a chance. But if you don't, you better get one. Otherwise, you're going to be tossed around like a freaking toy.